Hello everyone, this is DEBANJAN Mukherjee. In this video, I am going to analyze and design this 23-story building under influence of seismic load based on response spectrum analysis method and time history analysis method in CSI ETABS software. The building model is same one used earlier to demonstrate wind load analysis chapter of Skyfi Labs assignment. So let's get started. To start things with, I have already opened the model in background. So let's just open it. Here, as can be seen, the model is locked, so we'll first unlock the model. Here the model is unlocked. Now we'll go to define menu. To define the seismic load, we'll go to load patterns. In the load patterns menu, as can be seen, dead load, live load and wind load are already defined, so we'll just write down seismic. In the type, change it to seismic, and in auto lateral load drop down menu we'll select IS 1893-2002, the code. After that we'll click on add new load. As can be seen, the seismic load is added. Now what we'll have to do is modify this load. For that we'll click on modify load. We'll have to click on modify. Okay, now here we'll be clicking on, we'll untick the eccentricity options. We'll only apply X direction and Y direction load. Here can be seen that there are few factors which will have to be defined as per IS 1893-2002 codes. So these factors, such as the seismic zone factor Z, then their site type, then importance factor I, and response reduction factor R. These things will have to be put as per the IS 1893 code. We'll open the code. As can be seen, it is the IS 1893 part 1 2002 code. First of all, we'll check the zone where the building is to be constructed. For that we'll go to the map. As can be seen, the building has been constructed in Bengaluru. It falls under zone 2, which is colored in blue. So for zone 2 we'll have to check the zone factor. For that we'll go to table 2 of IS 1893 part 1 2002. As can be seen from the table 2, that for seismic zone 2 the zone factor is given as 0.1. So we'll be using 0.1 as zone factor. So for the next thing that we'll be consulting from IS 1893, we'll go to figure 2 to find the site type, the subsoil category. Here can be seen there are 3 categories, viz type 1, type 2 and type 3 for the soil strata upon which the building is to be constructed. Let us assume that the soil strata is medium soil, for which it is demarked as type 2. Now we'll be checking the importance factor. For that we'll go to table 6. In table 6, as can be seen, there are 2 categories, viz the first one is important service and community buildings such as hospitals, schools, monumental structures, emergency buildings like telephone exchanges, television stations, etc. For that, the importance factor is taken to be 1.5, but in this case we will be considering this particular building to be a residential one, for which the importance factor is taken to be 1. So we'll consider 1 as the importance factor. Next thing under consideration is response reduction factor. For that we'll refer table 7. As can be seen from the table 7, there are various types of structures or frames under consideration. For the building under consideration, will take ordinary RC moment resisting frame, for which the response reduction factor is given by 3. So we'll consider 3. So these things have to be put in this interface. For that we'll select the seismic zone factor as 0.1, then select the site type as type 2, then we'll select importance factor to be 1, then we'll change the response reduction factor to 3. Now we'll click on OK. Now we'll again click on OK, as our definition part is over for the load patterns. Now we'll be setting the load combinations. To set the load combination, we'll go to define menu. Under that we'll find load combinations. Here, as can be seen, the various load combinations are already defined over here, like the combination of dead load and live load, dead load, live load and wind load, seismic loads also. Everything is defined, so we'll click on OK. Now we'll go to analyze menu. Here we'll select on set load cases to run. As the wind load will not be under consideration for this analysis, we'll change it to do not run, while live load, modal load, dead load, seismic loads will be set as run. We'll click on run now. As can be seen, the analysis is under progress. From the bottom pane, usually takes a little bit time to analyze the entire frame. We'll wait till the analysis gets over. The analysis part is not yet complete. So analysis is over and the deformed shape can be seen in the 3D view tab on the right hand side. We can go to display menu to see various analysis results based diagrams from the drop down menu. Now we'll go to design menu and select concrete frame design. From there we'll go to start design check. Click on it. We'll click on OK. Now the design check process has started. As can be seen from the 3D view tab, various members of the building, the frame is being checked for the design flaws. can be seen, 9 concrete frames have failed the design. So we'll reiterate the entire process and click yes. In this process, from the auto select menu of beams and columns, the model will choose the next higher sections and replace them, and hence verify the design flaws once again. As can be seen with the revised members, the analysis part has started once again. As the analysis gets over, it would again check the design flaws. So the analysis is over, as can be seen from the deformed shape of the building on the right hand side. Again, the option is showing that some loading cases aren't under consideration. So we'll click on OK here. Can be seen that various members are once again being checked for the design flaws. Every time we reiterate the design check process by clicking on yes, it selects the next higher section for the failed members from the definition of auto select menu. As can be seen, this time around 7 concrete members have failed, so we'll click on yes to reiterate the analysis and design check process. As this thing usually takes a little bit time, we'll cut short the video here and again join once the design check is done. So our design check is over. With the defined loads, the design check has been completed, and we'll now check for the members that have passed. For that, we'll go to design menu, click on concrete frame design, and we'll click on verify all members passed. As can be seen, all concrete frames passed the design check, so we'll click on OK. So our analysis and design part of the building is completed. Now we can go to Model Explorer and click on Reports and find Summary Report option and double click on it to generate the summary report. The summary report will be generated on the Plan View tab. As can be seen, the summary report has been generated and the report viewer is showing the summary report. From this, we can check various design and analysis results. Based on the applied seismic load. So our seismic load definition part is over. In the next part, we are going to analyze this building in response spectrum method of analysis. So let's just open the model once again. Now we'll be unlocking the model once again to define the response spectrum and apply it on the building model. As can be seen, the model is unlocked. We'll go to define menu under that we'll find load patterns and click on it. In load patterns, we'll click on seismic load. We'll modify the lateral load. As can be seen, all the options are as per IS 1893-2002 already incorporated, so we'll not change anything. We'll keep these things as it is, and we'll click on OK to exit. We'll click on OK once again. Now we'll define the response spectrum. For that, we'll go to define menu and find functions and click on response spectrum. Here we'll choose function type to add menu and click on the drop down list, and in the drop down list we'll choose IS 1893-2002 as the code under reference. Now we'll click on add new function. In this particular dialog box, we'll change the function name to response spectrum. Now we'll change the seismic zone factor to 0.1 as defined earlier. Soil type will be changed to type 2. So our response spectrum function has been defined. We'll click on OK and click on OK again. Now close the report viewer. Now we'll click on options and click on display units to check the units used in acceleration. For that, we'll go to time related section and we'll check the acceleration unit is given by millimeter per second square. Based on that, we'll calculate the scale factor using the formula I into G by 2R. Now we'll go to define once again. Click on load cases. Here we'll click on add new case. Okay, there are 4 loads already, so we'll have to delete the wind load, as wind load is not under consideration here. We'll delete this case and click on add new cases. So we'll change the load case name to response spectrum. We'll change the load case type to response spectrum. Now we'll add load applied, and here we'll select load type as acceleration. Load name would be U1. Change the function to response spectrum. Change the scale factor to 1663.5, which is calculated based on the formula I into G by 2R and using acceleration unit as millimeter per second square. So we'll add another one. We'll change it to U2 for Y direction and change the function to response spectrum, again changing the scale factor to 1663.5. The rest of the values would remain as it is, so we'll click on OK. We'll click on OK once again. So our response spectrum load case is defined. Now up next we'd be going for the analysis and design of the structure. Now in response spectrum method, we need not to individually select any members of the building, as in the case of dead load, live load and wind load. Various shells and members were selected, but in this case entire building is under consideration in response spectrum. So we'll go to analyze and click on load cases to run. Select date and live load and change them to do not run, because only we'll be analyzing the seismic loads. We'll go to run now option and click on it. So the analysis is started. The progress is seen in the bottom pane. We'll wait till the analysis is over. As can be seen, the analysis is completed and the deformed shape is shown on the 3D view tab in the right hand side. So we'll click on display menu to select various analysis results, and the diagrams can be seen from there on. We'll click on design menu and select concrete frame design and click on start design check to run the design check. The design check is under progress. The model is currently being checked for the design flaws, and just like the previous case, it would be reiterated if any member fails to change their sections to the next higher ones from the auto select beams and columns menu. As the design check process takes a little bit time, we'll cut short the video and join once again when the design check is over. As the design check has been done now, we'll now go to design menu once again and click on concrete frame design to find verify all members passed option and check whether all the members have passed. Here can be seen all concrete frames passed the design check. We'll click on OK. So our design part is complete. So we'll once again click on Model Explorer tab to check the reports. We can click on reports and double click on summary report to generate the summary report. The summary report is being generated and would be reflected on the plan view tab. As can be seen, the report viewer has generated the summary report and various analysis and design results can be checked from this summary report. Now in the next part of the video, we'll be analyzing the seismic loads based on time history method of analysis. For that, we'll open the model, close the report viewer and unlock it once again. The model has been unlocked. Now we'll go to define menu. Here we'll be going to load patterns. We'll go to seismic option and modify this thing. Modify lateral load option is selected. Here we will not be considering the y direction of loading, as in time history analysis we'll only be considering the x direction of loading. So we'll click on x direction only and untick the y direction and click on OK, with all the other options remaining the same. Now we'll define the time history function. Again, going to define menu, choosing functions, thereon choosing time history, and the function type to add drop down menu is changed to from file. We'll be importing, we'll change the name to time history, here we'll be importing the time history file to use the time history data of the Bhuj earthquake that had happened in Gujarat. So we'll find it from the browse menu and from the internal folders of our computer. There will be a notepad file for that time history data. We'll click on it. As can be seen, it has been added. Now we'll open the notepad file once and check for how many header lines can be neglected. As can be seen here, 6 lines can be neglected from the header lines to skip and use the time history data. So header lines to skip option is changed to 6, number of points per line is changed to 1, and then the format type will select fixed format and change characters per item as 10, and okay, the names changed once again, so we'll again change it to time history or any other name as per convenience. We'll click on OK. Time history, we'll click on OK. As can be seen, the time history function definition is done and it is being reflected in the functions menu, so we'll click on OK. Now we'll be defining the load cases. For that, we'll go to define and click on load cases. Here, as response spectrum method is not going to be used here, we'll delete this load case. Delete case. Okay, now we'll be adding a new case. Add new case and change the name to time history. Change the load case type to time history. Then will be add loads applied. Here changing the load type to acceleration using the name U1. Function is changed to time history, and scale factor as shown earlier would be used as 1663.5. Remaining values remaining the same, so we'll click on OK. We'll click on OK again. The load cases have been defined, so we'll click on analyze and set load cases to run. Option is selected. Here, as can be seen, dead load and live loads are already set to do not run, and seismic and time history method is selected as run, so we'll click on run now option. So the analysis is being run on the building model currently based on the time history method of analysis. The progress can be seen from the bottom pane. As can be seen, the analysis is over and the deformed shape is being shown on the 3D view tab. Now we'll be checking the structure for design flaws. For that, we'll click on design and select concrete frame design. From here, we'll be going to start design check option and clicking on it. Click on OK. And the design check process has started for the entire model. As can be seen from the 3D view tab, various members are being checked for design flaws. We'll cut short the video. As the design check process is over, we'll join again. As the design check process is over, we'll check for the members that have passed the design. So we'll click on design, select concrete frame design, and we'll click on verify all members passed. As can be seen, all concrete frames passed the design check. We'll click on OK. So our analysis and design part is over for this particular building. Under time history method of analysis, we'll again go to Model Explorer, click on Reports tab. To generate the summary report, we'll select summary report and double click on it. The summary report will be generated in the Plan View tab. In the report viewer, as can be seen, the report viewer has generated the summary report. So our design check analysis have been performed, and we have learned how to apply the seismic loads on a building and check it by response spectrum and time history methods of analysis. This was a part of the Skyfi Labs assignment. Thanks for watching the video.